Hello everyone, welcome to my channel. Today I wanted to take up some of the basics in quantum computing that are superposition and entanglement. Coming to the introduction of quantum computing is basically an advanced field of quantum computing based on the laws of quantum mechanics. It is different from classical computing because it processes information using qubits instead of classical bits. Usually, in a classical computer, as we know, we use bits, and every information whatever we are processing will be converted into bits. Bit representation, we are very much aware of it. Each bit can be only either 0 or 1, whereas in quantum computer it uses qubits instead of bit. The main difference between bit and qubit is a qubit can be in state 0 or state 1 or both 0 and 1 simultaneously. Here comes the major advantage of quantum computing. This ability makes quantum computers extremely powerful for solving complex problems such as artificial intelligence, drug discovery, climate modeling, cryptography, optimization problems, etc. To achieve all these things, the main fundamental concepts behind quantum computing are superposition and entanglement. Without these two fundamental concepts, quantum computation is not possible. So, let me start with the introduction of superposition and what is superposition, why is it advantageous, and how is it applicable in quantum computation. So, coming to the introduction of superposition, superposition is a quantum property that allows a qubit to exist in multiple states at the same time until it is measured. Here comes the term until it is measured. This is very, very important. In classical computing, a bit, as we discussed in the previous slide in the introduction, a bit must be either 0 or 1, but not both at the same time. Whereas in quantum computing, it processes the data in terms of qubits. So here a qubit can exist in multiple states simultaneously, as mentioned earlier. And because of this property, it mainly can process massive parallel computation. So let us understand the superposition step by step. So in classical computing, only one state at a time is possible, whereas in quantum computing, multiple states are simultaneously. Where in classical computing, it can be either 0 or 1, as mentioned here, it can be either 0 or 1. Whereas in quantum computing, it processes the data in terms of qubits, so it can be both 0 and 1 at the same time, which is considered to be a major advantage for parallel processing. Whereas in classical computing, it is only sequential processing, whereas in quantum computing, it is parallel processing. So let us take some of the real-time examples of superposition which we see in our daily life. Best example which we usually discuss is for superposition is the coin analogy. So let us assume that we have one coin. So the coin, as we know, it consists of two states. One is the heads, the other one is tail. Just imagine the heads, the state is considered to be 0 and the tails considered to be as 1. While spinning, it represents both states together. Means once when we flip a coin and when the coin is in the flipping phase, we don't know whether the state is either 0 or 1. That is where exactly the principle of superposition comes into picture. As we discussed in the previous slide, the quantum computation mainly in quantum computing, it processes data mainly in terms of qubits. And we discussed about the states of qubit. It can be in 0 and 1 both simultaneously. In the same way, if we take the example, if we relate exactly to the example of spinning of a coin, when it is in the air, means when it is in the flipping phase, then it can be either in heads or tails, both at the same time. But once after it touches the ground, then only we can see whether it is heads or tails. That is what called as superposition. So here, as we discussed earlier, the superposition principle is broken once only when it is measured. So here in terms of coin example, once after it touches the ground, then once we go and see, then only we'll know whether it is heads or tails. But once whether if it is in a flipping phase, then it will be either in heads or tails or both simultaneously at the same time. There comes the advantage of superposition. So the data which is processed only once at a time can be processed parallelly in quantum computation with the help of the principle called as superposition. But here the main thing is, if it is measured, then only the principle of superposition is lost. So that is very, very important. This is the best example for superposition. One more advantage is, one more example is Google search analogy, and at the same time the best example is Schrodinger cat equation experiment. That is also one of the famous experiment done by famous scientist called as Schrodinger. So he uses a cat box and a radioactive element, and he places the cat, live cat, and the radioactive element inside a box. This is an age-old example, which was proven as the best example for superposition. So the box will be closed by placing the radioactive element and the cat inside the box. But the people who are seeing from the outside, we are not sure whether the cat is live or dead. And at the same time, the radio element slowly it decays. Once it starts decaying, then the cat may die. But we are not sure whether when the cat dies exactly. But how can we measure whether cat is alive or dead once we open the box? Once after the box is open, then only we can confirm whether it is alive or dead. This is one of the famous example for superposition. But once after the box is opened, then it will reveal the fact that whether the cat is alive or dead. So there the superposition principle is lost. And here comes the mathematical representation of a qubit state. So qubit state is mainly represented as kate psi is equals to a kate 0 plus b kate 1. Instead of a we can take alpha, and instead of b we will take it as beta. So kate representation, the kate representation, and kate 0, this 0 representation is called as kate, and this is also called as kate notation, kate 0 and kate 1. So the qubit is mainly represented in the form of kate notation. This comes from the Dirac notation, Bray and Kate notation, and here A and B are called as probability amplitudes. So these probability amplitudes always must satisfy an equation called as alpha square plus beta square is equals to 1. This means that the probability of finding the qubit in either state is always 1, and alpha is the probability of the coin. Suppose if it is an example of a coin, 0 can be taken as heads and 1 can be taken as tails. So A is called as a probability of having a chance of heads, and B is the probability of having a chance of tails. So the total it comes to 1. This is the concept of qubit state notation. So here comes the main notation called as Kate notation. So before measurement, qubit exists in superposition. This is what actually we have already discussed. Before measurement, a qubit exists in superposition. After measurement, the qubit collapses into either 0 or 1. This process is called as wave function collapse. And before getting into the concept of entanglement, let us have a summary of superposition, what we have just discussed. So superposition, the main advantage is it allows super parallel computation, and it will be helpful for faster calculation and simultaneous evaluation of multiple possibilities, where the advantage of quantum computation comes into picture, as it can process multiple things simultaneously. There almost the complexity of the problem to solve the problem, it almost reduces. So this is considered to be the major advantage and one of the basic principle of quantum computation. And mainly these are applied in artificial intelligence, weather forecasting, and in drug discovery, financial analysis, search algorithms. So these are considered to be the major advantages of superposition, like high computational power, faster problem solving, better optimization, efficient simulation, reduced processing time, etc. Next comes the concept of entanglement. Along with superposition, entanglement is equally important for quantum computation. So here to have an introduction of entanglement. Entanglement is a quantum phenomena where two or more qubits become strongly connected such that the state of one qubit immediately affects the state of another qubit. This happens even if the qubits are separated to a very large distance. So the large distance can be taken into consideration as suppose one qubit is on the Earth, the other qubit is on the Mars, which are almost separated at a larger distance. But still, due to the property of entanglement, there is a possibility of connectivity between these two states. So this is what the main concept behind entanglement. And as we mentioned earlier, measuring one qubit instantly affects the other, and strong correlation exists even over larger distance. To have a detailed understanding of entanglement, when these particles, I mean the two particles or the qubits, when they become entangled, their properties are linked. Measuring one particle automatically determines the state of other. So this relationship remains even when the particles are far apart. So the communication, mainly this entanglement helps in a very secure and faster communication. And to take the real-time example, um, there is a movie called as Judua where the two identical twins will be acting in a very similar manner even when they are separated distance apart. One person will be in one location, the other person is somewhere away in the far location, but still both of them will be acting in the same way in most of the situations. So that is the best example of the entanglement. That is a real time example. But Coming to some of the analogies which we have, uh, for example, one glove is, I mean, the hand glove, one glove is sent to India, the other glove is sent to America, which are placed in a box. So once after the box is opened and find a right hand glove, so we can assume that the other box which is present in America consists of a left hand glove. So entangled particles also behave similarly, but much more mysteriously. So people will be having few doubts on this, but once after we get into deeper along with the mathematical expressions, then the concept of entanglement will be understood easily. As we are just having an introduction session on entanglement, the basic example is the glow example, and the Judua movie example can be taken as the best example for entanglement. So the detailed explanation of entanglement will be given in the upcoming videos. So the main advantage of entanglement is secure communication, as I discussed earlier. And because of this secure communication, we have another subtopic in quantum computation called as quantum cryptography, which is very much helpful to secure data transfer. And these applications are already discussed about the applications of superposition, like drug discovery, weather prediction, AI, and machine learning. And the applications of entanglement are the quantum teleportation and quantum cryptography, secure communication, and quantum internet. These are the upcoming areas in which a lot of research is already happening in the area of quantum teleportation, quantum cryptography, secure communication, and quantum internet. So coming to quantum cryptography, it provides highly secure communication and teleportation. Here, the quantum states can be transferred from one location to another using entanglement. And quantum internet, like how we have 5G, 3G, it started with 2G, then now we are into 5G, 6G. In the same way, the future internet systems may use entangled particles for ultra-fast communication and highly secure networking as well. Why it is considered to be highly secure? Because on measurement, here also, once if we know that we have a right hand glove with us, we can easily predict that the other person who is in India has got left hand glove. In the same way, the two particles which are correlated to each other, once if we know the state of one particle, the other particle state can be easily identified. So this way, if any attack happens over the network or during the data transfer, with the help of the concept of entanglement, it can be easily measured. So only the main cryptography concepts comes into picture, and once the security is provided while the data is being transferred, then the communication happens very effectively with the help of internet. And these applications can be used in military communication as well, like in defense, not only military, in terms of defense, banking, national security systems, etc. So these are considered to be one of the few of the major applications of entanglement. And so the differences between superposition and entanglement are, the superposition mainly, the data will be processed in terms of qubit, where the qubit can have zero state and one state simultaneously. And coming to entanglement, two states of the particles are correlated, no matter how far they are separated, but still there will be a magic correlation between the two particles. And finally, coming to the conclusion, so the major advantage of superposition, it provides computational parallelism, and with the help of entanglement, it enables strong quantum correlations, because of which secure communication can happen. So therefore, to conclude on this, the superposition and entanglement plays a very major role in quantum computation. Thank you for watching and listening to the video.